Yeah, so the next panel is container-based systems, climate resilience at the intersection of resource recovery and sanitation justice. And first up, we have Ryan Smith and Alisa Keesey. Ryan Smith is a municipal wastewater professional and manages the wastewater treatment facility in Watsonville and has a bachelor's degree in agriculture from Cal Poly SLO and a master's degree in security studies from the Naval Postgraduate School in Monterey. And he interviewed Alisa for this research, and they've since become close friends while developing this unique pilot project together. And Alisa Keesey brings over 25 years of experience as a program officer to the program design and applied research that ground Give Love's EcoSan programs. And as co-founder of COVOL, she worked with women's groups and farmers to improve food security, increase household income, and establish the first fair trade shea butter cooperatives in northern Uganda. So Ryan and Alisa will be presenting obstacles and opportunities for disrupting flush toilets.
Ça marche alors. Ce serait quand même intéressant. Sinon, il faudrait chaque ligne. Comment ça fait que ça marche maintenant?
Hi.
So obstacles and opportunities for disrupting flush toilets, 3 case studies from Uganda and the USA. So take it away. Sorry.
Thank you. Trying to share my screen here. Just 1 second. Great.
Okay. Hi, everyone. I'm the director of Give Love, and I have been working on affordable sanitation systems for the last 15 years. And today we're going to just run through 3 quick case studies to show some of the opportunities and challenges of scaling container-based sanitations in low resource settings, but high need context. So our mission has been to improve sanitation coverage and integrate CBS with traditional WASH programming through technical skills training and environmental education. We've worked with about 24 NGOs in 8 countries. This is a water aid project in La Guajira, Colombia. And we primarily work in communities where people practice open defecation. So we started in Haiti after the earthquake, and many people don't know that the lack of sanitation was one of the big obstacles to rebuilding the city, because many of the donors could not build back better without sanitation. So Give Love did not win a successful Gates Foundation grant with the Reinvent the Toilet Challenge. However, we did do a 300 household pilot with Habitat for Humanity in 2011 and 2012. And at the time, it was the largest system that was community managed. It was completely low tech. We're talking shovels, no urine diversion. And we made about 32 tons of compost over 2 years, and all of it was used to grow food. So I think we may be the outlier here, because today we're going to talk a little bit about the problems with urine diversion and why we don't do it. So 4 billion people in the global south don't have access to sanitation. They're either reliant on some kind of, plastic bags, flying toilets, nasty pit latrines, shallow pit latrines, unlined pit latrines. This is in a peri-urban slum in Nicaragua. And what we were, really exploring is caring for the environment, caring for people by teaching people how to relate to their excrement in different ways. And this is just a person who's living on a dirt floor shack. And, obviously she's not going to have a toilet that's nicer than her house. But we successfully scaled about 100 families using on-site composting like this, with just tiny little lovable loos using the Joe Jenkins humanure system. So the question we have now is, how do we develop low-tech waterless toilet solutions and reclaim nutrients for reuse in agriculture without some of the high-tech systems that you're seeing here? There's obviously a high-tech bias in this industry. We think, you know, this work has to continue, but in the global south, if you want to call it that, how are we able to reclaim nutrients and protect water resources and do it in a way that's affordable and, you know, in reach of everybody?
So when I was doing my thesis research, I came across this concept that people in the wash sector know as the sanitation service chain. But for me, it was an aha moment. Being in the wastewater industry for, I think, 18 years at that point, I had never heard of this term. And it basically follows the steps of containment, collection, transport, and then treating human excreta and ultimate reuse or disposal of the material. I realized at that point that absolutely mimics the wastewater paradigm, you know, and so instead of conveying human excreta through pipes underground with water, we're basically containing it and transporting it above ground with some sort of carbon material as a medium to bind the material and prevent odor.
Oh, and the key point here is CBS allows for clean nutrient capture. The minute you start to try to reclaim nutrients from pit latrine waste, whether through desludging, dewatering, carbonization, dehydration, and a number of other processes, even, you know, black soldier fly won't even eat pit latrine waste. We've been doing some experiments with black soldier fly, and they love the fresh stuff. They are picky, and even flies know garbage when they see it. So, you know, one of the things that we want to say here is CBS allows for clean nutrient capture. So the first case study is citywide inclusive sanitation in Chebondo and Kamocha slum in Kampala. For those of you who don't know it, Kampala just had a massive waste slide, a 35-acre dump site slid off its foundation and, you know, killed about 60 people. All these drainage canals flow into Lake Victoria that, you know, so there's massive eutrophication and fish die-off. So we're really looking at this as a human and environmental justice issue, because 50% of the disease burden in Africa is caused by the lack of sanitation. So GiveLove was invited to work in these communities. They were already building their own compost toilets because the state cannot provide toilets in slums, but they didn't know how to compost. So we came in and we started, this is what we found. So then we started working with ghetto groups, local ghetto organizations, environmental activists, and we started, you know, just simply upgrading them a little bit. And this is just a, you know, a container-based toilet. There's no urine diversion here. We have about 50 of these in the slum, and they're used between, you know, by 50 to 75 people a day. We're also working with a group of disabled people in an intentional community called Lisa's Care, and they have these little toilets in their homes. And this is kind of what we found in the slum before we arrived. So you can just take a look at that. And I don't think anyone wants to recover nutrients from that. And this is, you know, kind of what we replaced these systems with. And here is the GiveLove team doing a, you know, bi-weekly collection in the community. And everything is processed thermophilically on site at a little compost depot. And it's actually now a training base for humanitarian organizations and a lot of agroecology groups just coming to learn more about nature-based solutions. And, you know, a lot of people talk today about the psychological and cultural barriers to recycling waste. And I'm a cultural anthropologist. I'm in a PhD program at UC Santa Cruz right now, writing about waste. And what we find is everyone will adopt humanure composting with proper skills training and environmental education. And so we're taking the compost and we're then doing secondary processing and working with the Ministry of Agriculture to amend the compost with rock phosphate and other locally available materials to make complete fertilizer formulas. For example, this is a formula called Super Maize, and we're working with local entrepreneurs and, you know, finding ways to do this at a, you know, very low cost and culturally appropriate way. And we're also promoting CBS in schools, because in schools we can, you know, compost massive tonnage. So this is a school in Kenya, and then next slide. All of the compost is used on site at the schools and used in kitchen gardens. So we're looking at, you know, mending these kind of environmental rifts, metabolic rifts locally, even if they're not exactly on site, but keeping this compost very close. And we're also promoting composting as skills for 21st century, you know, and working with government to kind of teach others. And I just want to end here with a little slide of Joe Jenkins. Joe Jenkins has been collaborating with us for 15 years. And we've been also doing some wash work in prisons in Uganda. And then for Standing Rock, we were invited this was the largest CBS project done in the United States. We were invited to work with the water protectors, and we did not urine divert because we couldn't. It was 40 below zero. The urine would have froze solid. So what we used is bio bags to freeze the toilet material over the winter, and then we composted it in the spring. And here is our finished compost site.
Yep. Sorry, I know we're at time. I'm going to talk real quick about the current pilot project that we're working on in Santa Cruz County. This is the biosolids drying area at the Watsonville wastewater treatment plant, where we're going to perform the composting of the material. We had to pivot the project several times due to primarily just the implicit biases of the county and state regulators and the County Environmental Health, the State Water Resources Control Board. But ultimately, we decided we would bring this back to my facility for treatment. And we know there's a huge need in the Santa Cruz Mountains. This is an example of one of the pilot project participants' homes. County building department confirmed that the #1 impediment to rebuilding after the massive CZU fire complex in 2020 is the cost of rebuilding septic. So the goal of this pilot project is to show a proof of concept following the sanitation service chain. We're going to collect material, transport it, treat it, and then test it at the end. And the goal here is to show the state regulators that this is possible and affect some level of change at the state building code. We talked about porta potties being somewhat infeasible. And this is our last slide. Go ahead.
Oh, so what we found in our research in California is that households are already using a version of container-based sanitation, but they're dumping the buckets and bags of waste in their trash or at county dump sites. So we, you know, recognize the county is not ignoring the problem, and, you know, we're conceptualizing the 4th pickup bin. If you go back one slide, these little totes are highly effective. We can transport about 50 or 60 pounds of excreta in these totes. And we're just using off-the-shelf equipment. And I guess the big barrier to diverting urine and source separating is that there's no off-the-shelf hardware to make it easy.
All right, we'll end it there, folks. Thank you.
Great, thank you so much. Those were very inspiring examples, and I really appreciated what you had to say, especially the idea that people will adapt with the training, the skills training, and the environmental education. I think that's what we found very much to be the case as well. Also, I forgot to mention earlier that if people want to put their questions in the chat, if you could say to whom your question was addressed, that would be very helpful. Thank you. So next up, we have Birger Lundgren, who I think Kai might have mentioned earlier, a Swedish serial tech entrepreneur and visionary investor who moved to Cape Town, South Africa 2 decades ago. With an extensive track record of innovation and business acumen, Birger has left a mark on the global tech and sanitation landscape. Birger will be presenting Next Generation Sanitation, a New Way.
Hello, everyone. Can you hear me? Yeah, awesome. The subject here is about school sanitation, and a short story. I've been in software all my life, and we had a draft here in Cape Town about 5-6 years ago, and we got started to import some toilets from Sweden, urine separation toilets, and we got in contact with the school, and they didn't have water all the time, and the flush toilet doesn't work without water. Well, you can use it for a while, but it's not so very nice to clean afterwards. But I will show you a little bit of our project here, what we're doing. And if we go to the schools here in South Africa and the toilet culture here in South Africa, we have about 3.9 million pit latrines. And most of these ones are full, and lots of schools, about 12,000 schools and 17,000 early childhood development have different kind of pit latrines. And this is a couple of pictures I have been taking when we have been out and visit schools. So you see the shed on the picture with corrugated steel. It's actually a toilet, and the one in the corner, you have like a pretty good view at least, and you can chat with your friend when you're using it. But it's what we find out is like girls don't drink water because they don't want to go to these toilets. The problem is also with the education for teenage girls. When they have menstruation, they have no place to handle it proper. So this is what we use. It's a Swedish urine separation toilet, and with a small flush function. And this small flush function with 100 milliliter of water is key, actually. Because when we installed it the first time in our pilot, they say, people, the kids and the teachers said, like, wow, we got flush toilets. And it's not really a flush toilet because it's container-based, but it gives a very nice experience for the user. And also it's a fan system that sucks out, so it actually smells less than a water-based toilet. I have it in one of my cottages in Sweden, and I really enjoy the experience of it. We also use rainwater for the flushing and also for washing the hands. And then we use here also Swedish technology. It's a small nozzle and a time delay tap. So you press the tap and it goes on for a short while and turns off. And you use about 200 ml, like a small glass of water to wash your hands proper. Okay. What we find out, the cost of building toilets is quite expensive, especially when you do them with brick and mortar. So we started to develop about 2.5 years ago, and like an IKEA method, flat pack, and using like Lego mechanics to build it. And if you see on the picture, there is a nylon connector that we could connect with aluminium. So the structure you see there is but the end of the first day. And this is the second, third day, depending on the configuration. It's a 3-seat toilet, and we can extend it. It's modular, so it can be like 6, or you can have 8, or whatever it is. We have created something we call the Sanitation Ambassadors, a service thing. And you see the container similar to what we saw in the last presentation, a container, but this is airtight. And we're using a technology that we developed together with the University of Agriculture in Sweden. And we use the method ammonia sanitation. And it's a very low-cost, clever way to take away the pathogens from the poop. We are doing now a quite interesting project together with Sanitation 360 to decrease the water level of the urine, and so we can use the urine in a more concentrated form in like community gardens and so on. So that's a part of what we're doing now, and we're launching the whole concept and on World Toilet Day together with the University of Johannesburg. The interesting part here when it comes to sanitation, University College London did a quite extensive research together with the organization Toilets for All, and sanitation actually hits all the 17 goals and several of the trade-offs also. So this is one of the first schools we did in Eastern Cape, very rural. And this is what we are showing the 19th of November on World Toilet Day at the university in Johannesburg. And we have just started the process and the project to develop, like fertilizer from the output here and the method with ammonia sanitation. And it's a pretty neat solution, and it goes quick to put up, and price-wise, that's the best of the thing. We are about half price compared to traditional buildings in the school environment. So it goes quick, and you can get more toilets for the same price. And you can also see the rainwater tank there. The rainwater we use for in the school environment. If you use normal flush toilets and normal basins, that tank will last for a school of 100 learners about 2 to 3 days. With the system we use and the toilets, it will last about 45 days. So it's quite big difference. So that's a little bit what we're doing here in South Africa, and we are the first one to take this to a larger scale when it comes to ammonia sanitation treatment. Thank you.
Great, thank you. That was also very inspiring and exciting to see those toilets. Okay, next up we have Lourdes Valenzuela, who is the Communication Director of Aguatuya in Bolivia and Latin America Coordinator of Sustainable Sanitation Alliance, or SUSANA. And she has a master's degree in integrated water management and a bachelor's degree in architecture, and over 20 years of experience in the water and sanitation sector, coupled with 9 years specializing in solid waste management. And Lourdes will be presenting on Nutriente recovery and reuse. Thank you, Lourdes.
Thanks, Tatiana. And just a quick note that Lourdes' presentation is pre-recorded and a bit long. So the end of it, we're actually going to be showing in our virtual tours panel on Thursday. So if you come back then, you can see a virtual tour of what she's going to be talking about in the last few minutes.
Okay.
Good morning or good afternoon. My name is Lourdes Valenzuela. I am the program coordinator for the Aguatuya Foundation in Bolivia. And today I'm here to present our experience with the implementation of urine treatment plant. English is not my native language, so I will do my best to read my notes in English as best as I can. We will see the importance of nutrient recovery and reuse. Let's talk about phosphorus first. Phosphorus is non-renewable resource, crucial for agriculture, as it is an essential component of fertilizers that promote crop growth. Rock phosphate reserves, the main source of phosphorus, are declining, and the future availability of phosphorus is severely compromised worldwide, because the reserves of this element in mines have been alarmingly reduced and are concentrated in a few countries as Morocco, China, and United States, raising concerns about the future availability and accessibility of phosphorus. If phosphorus extraction continues at its current rate of approximately 24 million tons per year, there will be supply problems from 2030 onwards. In the near future, once phosphorus reserves are exhausted, the only alternative left for living beings to continue to supply themselves with this element will be through its natural recycling. We can recover more than 90% of the phosphorus contained in human urine by implementing technologies that prevent phosphorus from being diluted in water. Ecological sanitation technologies, EcoSan, to recover phosphorus. NPK is a term that refers to the three fundamental elements in fertilizer: nitrogen, phosphorus, and potassium. So, phosphorus is essential for photosynthesis, respiration, and energy storage and transfer. It also helps plants flower and increases their resistance to diseases. Nitrogen is responsible for encouraging the growth of the plant's leaves and stems. A high nitrogen content results in vigorous growth, especially in early plant development. And potassium is key to water regulation within the plant. It helps the plant resist growth and diseases, improve its flavor and color, and is vital for the production of proteins and sugar. Therefore, the presence of these elements in manures and fertilizers can significantly impact the growth and development of the plants. The El Alto Plateau is located in the department of La Paz in Bolivia and involves the municipality of El Alto, Viacha, Laja, Achocalla, and has an estimated population based on the 2012 census of more than 900 inhabitants for this year. The Alto Plateau, as of December 2018, had a drinking water coverage of 93% and sanitation coverage of 78%. With the sanitation solutions that have been applied in greater proportion being conventional sanitary sewer systems. In order to achieve greater sanitation coverage, peri-urban areas, dispersed areas, complicated topography, it was necessary for the Public Social Water and Sanitation Company, EPSAS, to visualize alternative sanitation solutions and develop capacities to offer solutions. Decentralized sanitation solutions such as septic tanks, dry ecological toilets, decentralized wastewater treatment plants, or fecal sludge treatment plants. They are also sustainable by having a scheduled sludge collection service and its adequate treatment and final disposal. In the Alto Plateau, there was already a sustainable sanitation project from 2007 to 2019, implemented by the Suma Huasi Foundation with the Swedish Embassy. 1,200 families ecological toilets were built in District 7, 9, and 14 of the city of El Alto. During 12 years of operation of this sanitation model, it was identified that they needed a sustainable management model through the chain, from the collection, transportation, treatment, and final disposal of the waste generated in the ecological toilets to guarantee the continuity of this decentralization solution. The intervention the intervention considered a sustainable model with the participation of Swedish as financier, Aguatuya as responsible for the implementation and training in the solution, Public Social Water and Sanitation Company, EPSAS, as the person responsible for the service, and the beneficiaries from the El Alto Plateau have access to safe sanitation and through the services we recover their nutrients. The actions. A collection and transportation services for feces and urine from ecological toilets was implemented, ensuring continuity and sustainability. An adequate treatment system for urine and fecal sludge from a dry ecological toilet was implemented through a treatment system for urine and fecal sludge. Train EPSAS technical staff in the operancy and maintenance of the feces and urine treatment plant. Communicate to the population the actions to improve sanitation services by EPSAS with a green company approach. Service continuity is generated through sustainability throughout the sanitation service chain. The first link in the chain plays a key role, which is why it is important to schedule and comply with established times and dates. Information and communication to beneficiaries is important to avoid failures in the delivery and collection of generated waste. The plant has a fermentation treatment line, which was used before the implementation of urine adsorption treatment line 2. This type of treatment consists of receiving the urine in reception tanks with temporary storage for 2 weeks. Then the urine is pumped to 20-liter storage tanks for 3 months for fermentation and sanitization. Finally, it is pumped to storage tanks for final disposal as liquid fertilizer that must be diluted with water for application. Disadvantage of this option: the storage and treatment process cost, liquid transport costs, unpleasant odors during storage or application, rapid decomposition and additional treatment to maintain efficiency, risk of inaccurate application, overcoming preconceived ideas about the use of urine fertilizers, rate of acceptance of the population to the consumption of food fertilized with urine. The process of the adsorption is as follows: a storage of urine no more than 1 week to avoid loss of nitrogen, filling of tanks, preparation of the additives, struvite or bentonite mixture or zeolite, plus magnesium oxide to precipitate the struvite. Mechanical agitation for 35 minutes, emptying and resting for 2 hours, decanting to separate solid and liquid fraction, drain channel, drying on trays, complete drying in a solar oven for inactivation and or sanitization of the product, raise it to more than 90 degrees Celsius for 4 hours, usable time in the Bolivian plateau. Drying time of 4 to 5 clear days and 7 to 9 cloud days. And final storage for disposal or sale. The advantage of this of a solid urine product or fertilizer is because it's easier storage and transportation. It takes up less space and it is easier to store and transport. Reduction of odors, making the fertilizer easier to handle and apply. Greater stability and longevity without degrading or losing effectiveness. Precision in application, ensuring the right amount for the plants. Greater acceptance by farmers and the population. The result show an inconsistency in the analysis of potassium. However, it records an average recovery of 91% of phosphorus and 10% nitrogen. In subsequent monitoring analysis, the recommendation was to investigate laboratories that have a state-of-the-art equipment for measuring nitrogen and potassium, with the aim of having more accurate results and avoid interference or errors in the measurements of this. The plant was put into operation in August 2023 and will only complete 1 year of operation this August. We still have monitoring studies to do to show more solid results. In any case, in the first 6 months of operation, we were able to determine that the production cost is $3 per kilogram of dry fertilizer produced. Market studies are still needed to determine how much the product obtained can be sold for. The market offers fertilizers from $0.5 to $3 per kilogram, so we are in the price range. But in the production of our fertilizer, it should be taken into account that it provides access to safe sanitation and also ensures the closing of the nutrient loop, generating an environmental benefit that have high cost that we are not seeing. The implementation of this type of models project with sustainable sanitation service throughout the chain will also have a closing of the nutrient cycles, demonstrate that this type of solution are possible and highlight the importance of the paradigm shift for humanity to live in a sustainable way on the planet. So this is the end.
Okay. Okay, so see, I was gonna get the.
And just as a reminder, you can watch a virtual tour of some of their operations on Thursday.
Okay, great. So that was also very interesting. And we have one more in this panel. That would be Bara Wahbeh, who is the co-founder and CTO of AKYAS Environmental Consultancy in the United Arab Emirates. He holds an undergraduate degree in engineering and a master's degree in environmental science. And over the past 6 years, Bara and his team have been developing and refining on-site treatment technology to provide affordable and safe sanitation solutions for low-income communities. And in 2021, AKYAS Sanitation was awarded the Sarpati Sanitation Award. And Bara will be presenting the Effluent Diversion Unit. So Bara is up. What do we have to do?
Yeah, thank you for the introduction. Let me see my screen. Can you hear me properly?
Yes,
Can you
we
hear
can.
me properly? Yeah,
Yes, we
fantastic.
can.
Okay. Thank you. Okay. Here we go. Screen. Sure. Okay. So good day, everyone. My name is Bara. Currently, I'm in Kenya to put a new pilot. So we'll talk about it maybe if we have extra time at the end of the presentation. So our work is focused on pit latrine, and our work is how to transform pit latrine from a containment unit to on-site treatment unit. So why pit latrine? Simply because many people around the world use it. It's estimated 1/4 uses a pit latrine every day. And pit latrine simply is a hole in the ground. which act as a containment unit for whatever we flush from the toilet. However, most of the pit latrine do not have a proper lining, and therefore they leach the black water to the environment. And even if they have a proper lining, there is a lack of FSM value chain. So providing a proper emptying and transportation and treatment does not exist, simply because it's costly and the infrastructure is not there yet. So our approach is how we can transform these pit latrine from a containment unit to an on-site treatment unit. To do so, we need to understand what goes to the pit. So on average, a person would flush every time he goes to the toilet around 2 liters of water. Between urine cleansing water, more than 95% what goes to the pit is liquid. And less than 5% usually is a fecal solid. Our approach, if we manage to separate these two streams, we can enable the treatment of each stream separately. So we do this by using a plastic fitting. We call it the effluent diversion unit. We plug it to the existing pipe, any 4-inch pipe, and simply we divert both. The fecal solid will be diverted to pit number 1, and all the effluent we diverted to pit number 2. By doing so, we decrease the filling rate of pit number 1 between 10 to 20 times. And on the other hand, all the effluent can be treated on site and discharged on site. So basically, why to carry liquid from place to place or contaminate the liquid and let it contaminate the environment? So this is the approach. This is the system in operation. This is a small demo you can see here. We throw water with some solid waste. The water is passing by. Our unit has an efficiency more than 90% in separating, and it reached the primary treatment unit. Our current design of the primary treatment unit is made of 3 different technologies connected in series. The net area is 0.8 meters square. The first technology is a 3-chamber settling tank, followed with a biosand filter, and finally with a leach field. The system have a hydraulic retention time of 50 hours, and that will give you enough time to break down the urine and so on. The biosand filter will work with this microorganism to remove the BOD and other factors and the pathogen, and the leach field to discharge all the effluent good. Given the fact in most areas where we operate, mainly in Bangladesh right now, we have high water table, so we need to increase the space to discharge the liquid. To give you a glimpse of the power of the EDU, if you look to I'm just going to share one parameter, which is the BOD. If we have a sample reference with the 6,000 milligram per liter, and after the EDU, you will find it will drop to 105, which means the EDU have an efficiency more than 99% in removing solid waste. And at the system exit of the biosand filter, our BOD is 19. The reality it ranges between 85 and 19 up to this moment, which means the biosand filter is working properly. We believe to bring sanitation to the world, it needs to be market-based. The system you saw, it costs on average around $65 in Bangladesh. And we believe that if we want to scale it, we need to bring to our partners wealth. So maybe almost 70% of our system cost goes to our partners, because we only sell the EDU and we provide the partners with a blueprint to manufacture the settling tank and the biosand filter and the leach field. The model we're using, we're using the IDE SATO model, where the sanitation entrepreneur is the core component. We provide him with our units, and he will use or mobilize existing sales promoter and mason and pit emptier to household to do the installation. Lately, we have developed some communication media that they can reach out to people through their social media, mainly on WhatsApp, and that will make the communication a bit easier to explain what happened. And I think people in rural Bangladesh see the value, because they have a cost between $10 to $20 of emptying the pit on an annual basis. So this approach can really reduce their operational cost. So right now we're focused on the pit latrine because we don't want to spread fast. Right now we are in Kenya, we're building public toilets in schools with the same technology, but the technology is eligible to both household and multi-story building. And also in Bangladesh right now, we're putting like a dozen of units under different organization names. So we're partnering with IDE. and NGO Forum, and Finish Mondial. So yeah, we managed to put a proof of concept since last year. Our unit have been operating for more than a year. They have survived the monsoon season. Amazingly, the unit continued to operate fantastic after heavy flooding. They were flooded with like 2 meters of water above them for 2 weeks. People noticed like way less odor coming from the pit and less dislodging causes happening to them. We managed to sell the units to people. People are paying for them, especially after the monsoon season and the flushing event. They saw the system is resilient, so the neighbors came and bought more units. And our next step is to mass scale manufacturing and bring this unit to global world. So we're looking for partners who are interested to implement anywhere in the world at different contexts, to partner together, team up, and put more units together. And yeah, thank you.
Thank you, Bara. And that's concludes the number of speakers for this panel. Very interesting to hear all those different approaches and strategies. So now we have some time for some questions. I don't know if there were questions. Okay, we have some questions here. See if I can read them. It's just the just the highlight. Okay, for Andy, from Andy and Michelle to Bara, how does the solid and liquid separator PVC, T or Y work? That makes sense.
I'm not sure what does T or Y means. Maybe it's a plastic fitting. We design it with a specific angle. We use the momentum of the flush water to push things forward and separate based on momentum, honestly. Yeah. I hope that answers. And it's designed with a universal fitting to fit any 4-inch pipe, because we found out that in different countries, 4-inch pipe have different nominal diameter. So we designed it to fit different 4-inch pipe.
Okay.
So the solid, I see another question.
Yes,
the solid goes to pit number 1, and they fill there. What we found out that the solid, the fecal waste get dehydrated in 2 to 3 weeks and lose like big amount of their volume. But what we're implementing right now, we use tiger worm, so they really they reduce the accumulation rate. We believe the accumulation, the filling rate of the pit latrine can be up to 5 years. The urine with the flush water will go to pit number 2, where the treatment will happen. So we developed a 3-unit, 3 technologies connected in series. If you want more information, you can send us an email. That would be like, maybe I can share more information on that.
Are there questions in the room here? Are there any questions from the room here? There's a question here.
So where do you come up and use the computer? So if I have a question, then you can come up and make a line. You can be effective without time.
My question is for the Give Love team. You mentioned culturally appropriate ways and like low cost solutions, or what you prioritize. And I was wondering if you could speak more on like what you mean by culturally appropriate ways, depending on the different settings you're working in. Thank you. And great presentation.
Right. So a culturally appropriate technology is, first of all, acceptable, affordable, improves public health, works in a context, is scalable in a context. And, you know, we're looking at giant cities in Africa growing that cannot meet the sanitation service gap. So that's what I mean by culturally appropriate. And also there is there was a general sense, even by the government of Uganda, that people won't work with feces. But what we know is informal waste workers, when they're given proper training and PPE and a dignified job, they're quite willing to do black soldier fly work or composting. It's actually a lot cleaner than emptying a dirty pit latrine with a gulper or other methods that have been used. So that's what I mean by culturally appropriate. And also, we didn't mention it, but with menstrual hygiene management, right now, all across Africa, schools are burying menstrual pads, and they're thousands a month, or incinerating them, but they're not able to incinerate them because they're plastic, they're wet with blood. So they're just a nuisance. But composting allows you to culturally appropriately bioremediate a lot of organics, on site, or do a service. But we're one of the only organizations doing CBS in rural contexts and refugee contexts, where we're about to start in Naku Valley refugee settlement.
We have a question why we don't separate urine. I think number one, it's just easier to manage one stream, so to speak, rather than two materials, one solid, one liquid. And then also for the composting, we really need that carbon to nitrogen ratio. So we need that nitrogen in the urine to successfully achieve the thermophilic composting. I think I see another question about a subsidy.
Yeah.
There aren't any ALISA secured funding through a high wealth individual, net worth individual. The county also had I think it was called a core grant or something like that, but we missed the mark on getting our application in on time because we were really in the infancy stages of the pilot project, and that was about 2.5 years ago.
Yeah, and then Remy, your comment there, I think the technical report of findings will lead to a stage 2 and try to figure out what a service might cost for tiny homes here in the county, because they're definitely interested in using CBS on the bike trails, beaches, and to expand tiny home communities. So, and also this population can afford to pay for sanitation, whereas in a Kampala slum, we're definitely working with authorities now on subsidized services there.
The technical paper, this one, from Alyssa and Ryan to Bara.
Okay, from Alisa and Ryan to Bara, asking Bara, do you have a technical paper?
We will have a technical paper.
That was to Bara.
To Bara, sorry. Right.
We do have technical papers. I can share it if you can reach out via email. I can share it to you for sure. Yeah.
Thank you. We will.
How do you balance? I don't know. Does anyone want us to talk about?
Yes, this is a question from Tricia Nickerson, wants to know, how do you balance the trade-offs from adding phosphate rock to make pellet fertilizer versus just composting?
So I don't know if anyone's following kind of the impact that the Ukraine-Russia war has had on fertilizer prices in Africa. So it's really about utilizing organics at a nation state level for food sovereignty and food security. So, right, you do balance, they want to be self-sufficient in organic fertilizer production. They're starting at the 0 level. I mean, even the Biden-Harris administration just gave almost $1 billion to do organic fertilizer in the United States. So I think this is a big question that everyone is looking at right now.
Also, if anyone hasn't heard the term peak phosphorus, check it out. It's a big problem. I would say it's a below the horizon issue currently, but it's a finite resource, and not a lot of it is here in the United States.
It looks like there's another question from Carol.
Oh, no, it's just a comment.
Oh, it's a comment.
Same questions.
Okay, I think we're just about at the end of our time. So did you want to say a few words? Okay, final round of applause.